Copy and complete the table for the relation y equals to 2x squared minus x minus 2 for values of x ranging from -4 to 4. This is the table. Question number B, it says using a scale of 2 cm to 1 unit on the x-axis and 2 cm to 5 units on the y-axis, you have to draw the graph of y equals to 2x squared minus x minus 2 for the same range of values of x. Question number C, on the same axis, draw the graph of y equals to 2x plus 3. And question number D, use the graph to find Roman 1 roots of the equation 2x squared minus 3x minus 5 equals to 0. And Roman 2, range of values of x for which 2x squared minus x minus 2 is less than 0. So let me attempt to answer all those questions. Solution to this: first is to answer question number A, that I'm asked to copy and complete this table, and this table is for this relation y equals to 2x squared minus x minus 2. So let me copy the table as it is. This is the table exactly, I copied it, so I'm to complete it. Completing it means where the spaces are empty, I should find the appropriate values there. The value of y here is missing, I am to find it. The value of y here is given, here is missing, here is also missing. So where I don't have values of y, I should find the appropriate values for y in there. So in doing that, I'll copy the equation because it says y equals to 2x squared minus x minus 2. So it is the corresponding value of x. I'll keep substituting in that very relation to find the appropriate or corresponding value of y. So copying that equation, y equals to 2x squared minus x minus 2. This is the relation between x and y. So first, to get to y over here, I will now replace the x by -4. So replacing x by -4 in here, whatever I have finally will now be the corresponding value of y when x is -4. So substituting x by -4, I'll have 2 multiplied by -4 whole squared. X squared is now -4 squared. Minus -4, replace the x by this -4, then copy the -2. -4 square is 16, positive 16 times 2 is 32. Then minus is plus, then -2. So I'm going to have -4 square is 16 times 2. Then minus would now change to plus. Then I copied this -2 and multiplying this, adding and subtracting, I'll have 34. 2 times 16 is 32. 32 plus 4 is 36. 36 minus 2 is 34. So the value of y when x is -4 is going to be 34. So I'm going to write 34 here. So this is 34, the corresponding value of y when x is -4. So I did the same for all those values. So next I'll take x as -2, replace it like I did here. It will give me final value 8. I will now take -1 as my x, replace it in here and get the value of y there. So it is going to be 1. I'll continue, replace the x by 1. It will give me the corresponding value of y as -1. Replace the x by 2 in that very equation. So what I have finally is y, so that y was going to be 4. Replace the x by 3 in that relation, the final value will be your y, so that y is going to be 13. So this is my table. Showing of how you work this out is not very necessary, only we are marking the values in the table. So I'll continue with question number B. Question B says I should draw the graph using this very scale, 2 cm 1 unit on x-axis and 2 cm 5 units on y-axis. I am to draw the graph of this relation. This is the table I obtained before I have completed. So this is my graph sheet. So what I will do first is to draw the axis, the x-axis and the y-axis, and number it appropriately according to the given scale. So this is my x-axis. Look at it. The horizontal axis is the x-axis. So let me attempt to number it. This is starting from -4 up to 4, and it says 2 cm 1 unit. So from here to here is 2 cm, -3, -4, -3, -2 up to 4. Then I'll draw my vertical axis, that is the y-axis, and the y-axis it says 2 cm 5 units. So I have this also. This is the numbering. So each 2 centimeter represent 5 units. So from here to here is 5 units. From here is another 5 units. Here to here another 5 units. Each 2 centimeter is 5 units. So next is to plot these values. When x is -4, y is going to be 34. So I'm going to find the appropriate position of this when x is -4, meaning move to the left hand side of the x-axis, locate -4, and move to y-axis, locate 34 there. According to the given scale, you have to know how to read it correctly. So this is x -4, and y34 is somewhere before 35. So somewhere, because each 2 centimeter there will be 10 small divisions there, and because 2 centimeter represent 5 units, so each 2 divisions will be 1. So I'm going to have 34 somewhere. 2 divisions under this 35 is going to be 34. So I'm going to mark it like this. I'm going to make a little cross here. Going down is x -4. Moving like this is y34. So this is it. So this is the first point. I'll continue. The next point is going to be x -3, y19. X -3, this is the position. Y19, 19 is also 2 small divisions below 20. So this is the position y19 and x -3. If I continue the next point, x -2y8, x -2y8 is going to be somewhere here. Look at it. X -2y8. Y8 is just 4 divisions below 10. 4 small divisions below 10. This is x -2y8. I'll continue. The next is x -1 y1. X -1 y1 is going to be somewhere here, just 2 small divisions on top of that line. I'll continue. Next point is x0 y -2. X0 y -2. So on the y-axis I'll locate where y is -2. Y -2 is 4 small divisions down this x-axis. So I'm going to have something like this. This is the position. So I'll continue like that. When x is 1, y is -1. I'm going to have it here. When x is 2, y 4, I'm going to have it here. When x is 3, y is 13, I'm going to have it here. And finally x4, y 26, I'm going to have it here. X4, y 26. So with this I have marked those points. What remains is to use my broomstick or French curve or freehand. If you can draw smooth curve, you are going to join all those points with a smooth curve. So that is what I'm going to do next. To do that, you use your broomstick or you use French curve, or you can even use freehand to join them. All we need is smooth curve. So the curve will look like this. Look at it. Look at it. This is the curve. If you draw it, this is the curve. So I will now continue. Question B has been answered. So I'm going to answer question number C. Question number C says, on the same axis draw the graph of this relation y equals to 2x plus 3. To draw any graph, you have to have a table of value. So I'll have a small table for this also. So as this is a straight line, it's not quadratic, you can even use just 3 values of x there. So I decided to take the last, first and last, then somewhere middle. So I have x minus 4, x0, x4. You are very much free to take any 3 values here. So this is the one I decided to take. It will going to give me straight line. So 3 points are enough. So I'm now going to have y when x is minus 4 from this relation. Replacing x by minus 4, I'll have 2 times minus 4, which will be minus 8. Minus 8 plus 3 is going to be minus 5. So I have minus 5 when x is minus 4. Replace the x also by 0 in this relation. Y equals to 2x plus 3. So I have 2 times 0, which is 0 plus 3. So y will be 3. So I'm going to have x as 4 now. So 2 times 4, 8. 8 plus 3 will now be 11. So this is my small table, which I'm going to plot this 3 points also, that I will join it to give me this question number C. Says draw the graph of this. So let me get this, let me mark this also. X is minus 4, y is minus 5. X minus 4, this is x minus 4. Y minus 5 is somewhere here. Look at it. So this position will now be x minus 4, y minus 5. Look at it here. I'm going to take the next x0, y3. Y3 is somewhere here, y3. Just one small division after this line, or 6 small divisions above line x-axis. So that will be y3, and x is 0. So look at it here. Then I will take the last x4, y11. x4, y11. This is x4, y11. 11 is just 2 small divisions above 10. That will give you 11. So these are the 3 points, 1, 2, 3. So I'm going to use my ruler now to join those 3 points. I'm going to have a perfect straight line. So joining them will give me this line. Look at the line blue. So with this I have answered question number C. I draw the graph of y equals to 2x plus 3 on the same axis I have drawn the first one. So I'll move to the last question, or last questions. Last question says I should use the graph to find roots of the equation 2x squared minus 3x minus 5 equals to 0. So let me attempt to find these roots. What you need to do is to check, is this exactly the quadratic that you have drawn? If yes, go ahead and find the roots. If no, you have to modify it so that it resemble, at least the left hand side of it now resemble exactly the quadratic that you have drawn. So the quadratic that we have drawn is 2x squared minus x minus 2, not minus 3x minus 5. So it differ in these 2 terms. It's supposed to be minus x here, and it's supposed to be minus 2. So let's me modify it. This is 2x squared minus 3x minus 5 equals to 0. The one that I'm asked to find it is roots. So I have to modify it so that the left hand side now resemble exactly the one that I have drawn. To do that, I have to change 3x minus 3x to minus x. I have to change the minus 5 to minus 2. So what I will simply do, I will add to both sides. It's very much allowed. So I add 2x, positive 2x. I also add positive 3. That will enable me, if I combine this positive 2x and minus 3x, it will end up with minus x. And minus 5 plus 3, it will end up with minus 2. So this is what I need to do, so that I will modify this left hand side to resemble exactly the quadratic that we have drawn. So this will give you x squared minus x minus 2 minus 3x plus 2x, it will be minus x, minus 5 plus 3, it will be minus 2. Then this is what you have by the right hand side. But looking at the right hand side also, and looking at the straight line that we have drawn, y equals to 2x plus 3, they are also the same. They resemble. This is 2x plus 3, this is y equals to 2x plus 3. So this straight line that we have drawn, this is the relation y equals to 2x plus 3, and it the same thing with my right hand side here. So the roots of this would now be nothing but where the curve crosses the straight line, because the right hand side is your straight line while the left hand side is your curve. So you locate the 2 points where the 2 graphs intersect or crosses each other, go to the x-axis, find the values there. That will be your roots. So the roots will now going to be the value here if you go to the x-axis, and the value here if we go to the x-axis. So I will now draw a line vertically down, straight line vertically down. Look at it. This will now be one of the value or one of the roots, and this point where the cross going down to the x-axis, this is another value. So the values there, this is going to be -1 exactly, and this is going to be 2.5 exactly. So the roots is now going to be -1 if I consider it to be here, I beg your pardon, or 2.5 if I consider it to be here. So these are the roots of this very equation. 2x squared minus 3x minus 5 equals to 0. Simply modified because it's not exactly the quadratic that you have drawn. What you have by the right hand side, if you have not drawn it, draw it. So let me move to the last question, which I'm asked to find range of values of x for which 2x squared minus x minus 2 is less than 0. This is the curve. This is the curve. 2x squared minus x minus 2 is my curve now. So I should locate where the value of x happens to result in values of y less than 0. If you go down here where it crosses the x-axis, the value of y there is 0, and where it crosses x-axis, the value of y there is 0. But this down is where you have value of y less than 0. So these are the range of values of x we are interested in. So where the curve crosses the x-axis, the value here will give me the range of x in which the corresponding value of y there within that range is less than 0. So I'll get this according to the scale. This value and this value of x will now give me the range. So the range will now be x from here. This is -1, x minus 1. So you estimate here, the estimated value is -0.7. It's about 7 small divisions from 0 to this. So it's -0.7. And here is 1.3, about 3 small divisions after 1. So this will now be the range of values of x in which the corresponding value of y there is less than 0. So with this I have answered all the questions in this question number 7. Now let's go back and see the mark distribution according to the marking scheme for this. The very first mark is B3, the bonus 3 marks for the table. For completing this table, you have 3 marks bonus if all those entries, about 6 entries, are correct. 34, 8, 1, -1, 4 and 13, if all are correct, you have this B3 marks. For those that are wrong, it is going to be -half for each wrong one. So for completing this table correctly, there will be 3 marks. And moving to the graph, there is 3 marks, bonus 3 marks for plotting these points and joining them accurately. You have bonus 3 marks. And for drawing this straight line also is another bonus 1 mark. So this is for question B and question C. You have B3 for the curve and B1 for the straight line. And for answering those questions, meaning question determining the roots of 2x squared minus 3x minus 5, this is the mark distribution. So the first mark is the method mark, where you attempt to read the point of intersection of the curve and the straight line. So attempting to read from there must be this line, attempting to read the point of intersection here and here. So you have method mark there. And for the answers accurately, in the -1 here, you have A1, and the x 2.5 here, you have another A1. But in this case, you may have the same marks, A1, A1, even if this x is not exactly -1, but somewhere -1.1 or -0.9, meaning there will be an allowance of deviation of plus or minus 0.1. Similarly, x equals to 2.5, even if it is not exactly this, but it's somewhere x 2.4 or x 2.6, you still have this A1. There will be a deviation of plus or minus 1, 0.1, I beg your pardon. And then last is method mark, where you are reading this, meaning you are trying to find the range. You are trying to read where they intersect x-axis, the curve. So you have this M method mark, and for your answers to be accurate, 0.7 negative, and 1.3, you have this A1. So here also, even if it is -0.6 or -0.8 and 1.2 or 1.4, you still have this A1. So there will be a total of 12 marks in this very question number 7.